Alright, y'all, so in this video we're going to be looking at a very similar concept to arc length. But this time it is the sector area of circles. So first thing we need to know for this concept is the area of a circle. And remember, the area of something is just the amount of space inside that object. So in this case, it's the amount of space inside the circle. It's the filled in area. And we should know that the area of a circle is pi times the radius squared. So if our area equals pi times the radius squared, let's say we have a diameter of 20. Now, if our diameter is 20, that means that our radius is 10. So our radius is 10. So if the diameter equals 20, then the radius equals 10. And so we can use our equation to find the area of a circle. Area equals pi times the radius 10 squared, and that's 100 times pi. So if the area is 100 pi, that is about 314.2. So this is the area of a circle. Follows this equation. We've used this before. We hopefully should have used this before at least. And it just follows that equation. You just have to have your radius, plug it in, and you'll get your answer. Well, just like the arc length of a circle is just like the arc of a circle is a fraction of the circumference, the sector area of a circle is a fraction of the total area. It's like a piece of pie. It's a pie-shaped slice of a circle. That's what a sector of a circle is. And it is between two radii, or two radiuses, and an arc of the circle. So if we have an arc here, we talked about arcs last time, and a radius here, and a radius here, this equation will allow us to find the area of just that slice. Not the whole circle, just that slice. And the area of a sector can be found by finding a fraction of the area of a circle. Just like the arc length was found by the fraction of the circumference, this is the fraction of the area of the circle. And it follows this equation. The area times that same fraction, whatever that angle is, out of 360. So we saw that fraction in our last lesson, theta out of 360. It's here again. Theta out of 360 is going to give us the fraction of our circle. That number times the total area will give us the sector area. And if we look at our first example here, on example 7, I know these numbers don't exactly line up with the previous page, but that's okay. We know the area equals pi times the radius squared times the fraction that we're actually finding. And we're given a radius, we're given an angle, and those are the two things that we're going to plug in. So the area equals pi times the radius. The radius is 6 times our angle, 165 out of 360. And we want to plug that into our calculator. Once you do that, you should get your answer. I'll give you just a second to plug that in or get caught up. Remember, if I'm going too fast at any point, just slow down the video, pause it, do whatever you need to do. And we know that the area equals about 51.8, and that's in yards squared. The unit is yards because it told us that. And since we are dealing with area, area is always squared. Okay, if you got that right, should be good to go, but let's look at another example just to make sure. And we want to write down the equation every time. Area equals pi times the radius squared times theta over 360. And that equals pi times the radius of 16 squared out of 210 is our angle over 360. Plug that into your calculator and you'll get the answer. Pause it if you're not quite done. And our area should be about 469.1 centimeters squared. We're in centimeters, and area is always squared. Now, if you got both of these correct without me, you should be good to go. If you didn't, pause the video or rewind it and go back and watch these again. Make sure you know how I got these answers. Then I want you to try questions 9 and 10. Go ahead and pause the video, try those on your own, and then I'll give you the answers in a second. On question 9, the area should equal 96.2 kilometers squared. And on question 10, the area should equal about 254.5 meters squared. If you got those two answers, that's great. You got them all right. And if you did not, look at the examples again for questions 7 and 8. This is the formula right here. If you have your radius and you have your theta, should be good to go. Plug it in. Make sure you're plugging it into the calculator correctly. And make sure you're plugging in the radius and not the diameter. If you plug in the diameter, you're going to get it wrong. So don't do that.